Hello friends, today I am going to tell you about the shielded metal arc welding electrodes. Okay, shielded metal arc welding electrodes. See, I am having one welding electrode in my hand, so I will show you. See, this is our electrode. Okay, and this electrode is covered with the flux. Okay, see, this gray color substance is the flux, and this black color it is the metal. Okay, so this metal is covered with the flux. Okay, so this is our arc welding electrode, shielded metal arc welding electrode. So before moving forward, I'll tell you about the function of the flux. Okay, what is the function of the flux? See, this flux produces fumes. How? When we do our welding, this flux get decomposed. Okay, due to the high heat, this flux get decomposed and it emits fumes. Okay, and those fumes, they cover our weld pool. They cover our weld pool from the atmosphere. Hence, it prevents oxygen hence it prevents oxidation. Okay, hence our weld metal gets shielded by the fumes of the flux. Okay, and then this flux is very light in density. Okay, this is lighter in density as compared to the metal. Hence, this flux come upwards. Okay, come upwards on the weld pool. Okay, and this shields the weld pool, and hence the heat transfer is slow. Okay, hence our weld pool slows. Transfer of heat is very slow, even just because of this covering of this flux. Okay, and our third function is reignites the arc. See, in DC welding it's okay, but in AC welding, see, in AC welding the waves are like this. Okay, it goes positive then negative, positive then negative, positive then negative, and it changes its polarity 100 times in a second. It changes its polarity 100 times in a second. Okay, so when it comes to zero, this arc extinguished. Okay, when it comes to zero, the arc get extinguished. So this flux helps in reignites the arc. This flux helps in reigniting the arc. Okay, see, we can't see this with our naked eyes because it happens 100 times in a second. That's why we don't see it with our naked eyes. Okay, so these are the three functions of electrodes. First, it produces a fume which prevents the weld metal from oxidation. Then this flux material floats over the surface of the weld metal and it prevents from faster cooling, and then it reignites the arc. So these are the three functions of the flux. Okay, now I'll tell you about the welding electrodes, how it is designated. See, our welding electrode is designated by E7018 or E10018. Okay, E and then 4 numbers or 5 numbers. Okay, so this E stands for electrode. E stands for electrode. It's a shielded metal arc welding electrode. Okay, and the first two letters of the 4 letters, first 2 numbers of the 4 numbers, or first 3 numbers. If the numbers are 5, then first 3 numbers. See, here 4 numbers are there, 1, 2, 3, 4. So if it is 4 numbers, then first 2 numbers designates the minimum tensile strength of the electrode. So in 70, this 70 is 70. So this is minimum tensile strength is 70,000 psi or 70 ksi. 70 ksi or 70,000 psi. Okay, this is the minimum tensile strength. Okay, see, we have 4 numbers here, and in here this electrode has 5 numbers, 1, 2, 3, 4, 5. Okay, so in 5 numbers, the first 3 numbers designates the tensile strength. So here it will be the minimum tensile strength will be 100 ksi or 100,000 psi. Okay, psi is pounds per square inch and ksi is kilo pounds per square inch. Okay, so when we divide psi by 1000, we'll get ksi. So in 7018, our minimum tensile strength will be 70,000 psi or 70 ksi. Okay, and this letter, third number, this letter second last number is 1. This designates the position. Okay, positions means in what position this welding electrode can be used. Okay, in which position this welding electrode can be used. So 1 designates the all position, means this electrode can be used in all position. Okay, 1 designates the all position. I'll show you the other positions also. 1 is all, 2 is flat and horizontal. So to weld the flat and horizontal welding, we need an electrode which has 2 in number. Instead of 1, we have 2. And 4 is flat, horizontal, vertical and overhead. Okay. See, don't get confused with 1G, 2G, 3G and 4G. Okay, see 1G, 2G, 3G and 4G and 1F, 2F, 3F and 4F are welding positions, whereas in this electrode, these positions are different. These are shown that in which position we can use this electrode. Okay, so that is different from that welding position. Okay, so we have understood what is E7018. 7018 means 70 KSI or 70,000 PSI, and 1 is position. Now, the last two numbers together defines the flux and the polarity. Both flux and the polarity means what flux this electrode is using and in which polarity the electrode we have to use it. Okay, so I'll show you the flux only. See, here if it is 0 in the last, then it will be cellulosic, 1 in the last, then cellulosic. If 2 in the last, then titanium oxide. Likewise, we have titanium potassium, iron powder, low hydrogen sodium, low hydrogen potassium, iron oxide, low hydrogen potassium or iron powder. So like in E7018, we have 8. This is low hydrogen or iron powder. So the flux which is being used in E7018 is low hydrogen potassium or iron powder. Okay. If you come to E10018, here 100 means 100, minimum tensile strength is 100 KSI or 100,000 PSI. 1 is this electrode can be used in all positions, and this 1 and 8 both defines the polarity, and this 8 shows the flux, and in this case it is iron powder. Okay. Likewise, we have two very popular welding electrodes in cylinder metal arc welding. One is E7018 and the second one is E6013. Okay, E6013, and I am having one E6013 in my hand also. So in E6013, as I have told you, 60 means 60,000 PSI is minimum tensile strength. 1 is it can be used in all position, and 3 means the flux composition. It is titanium or potassium. So the flux will be titanium potassium.